Hello, everyone. Welcome. Hello, everyone. Welcome. Hello, good afternoon, everybody. Welcome, welcome, welcome. So welcome, good morning, good afternoon, good evening, depends on wherever you're watching us from. Welcome to another amazing boot camp of Amdoranalytics. So today we'll have an amazing guest. We have an amazing facilitator in no other person than Emmanuel Ani. So Emmanuel will be taking us on our journey today on AI engineering boot camp. Right. So before we proceed, please kindly share the link to everyone. Kindly share the link to your family, friends, anyone at all you know that is actually interested in transitioning into tech. Please do diligence by sharing this link, sharing the link to everyone. Please kindly confirm you can hear me.
I can hear you, Chika. Good
Okay.
afternoon.
Hi, good afternoon, Emmanuel. Welcome. And while Emmanuel is still trying to get ready to take us on an amazing section today, please, I would like you share the link. Let us all share the link to all our family, our friends, to everyone who we know is interested in transitioning to tech, or anyone who is already in tech and wants a career upgrade and wants a skill upgrade. If the person is already in tech and the person requires a skill upgrade, please kindly share the link of this section to the person. So this section promised to be very insightful, very knowledgeable, very amazing, interactive, and interesting. Right. So before we go get into the day, into the real matter of the day, I would like to share my screen and introduce Amdoranalytics and everything we do at Amdoranalytics. All right. So kindly confirm you can see my screen.
I can see your screen.
All right, so thank you. So before we proceed for today, I would like to introduce Amdoranalytics, what exactly we do and who exactly this training is for. So at Amdoranalytics, we are committed to empowering individuals to become global talent through our comprehensive and accessible training programs. Our mission here is very simple. Our mission at Amdoranalytics is to bridge the skill gap by equipping learners with in-demand skills, enabling them to make informed decisions, drive innovation, and create positive change in a tech-driven world, particularly across the African continent. So we have here at Amdoranalytics, we have a track record of helping over 8,000 participants. Yes, you heard the right, 8,000 participants successfully transition into tech. So we specialize in a couple of trainings. We specialize in trainings like data analytics, business analysis, cybersecurity, data engineering, HR analytics, AI engineering, just like we are about to dive into the section, project management, data science, and AI automation automation. Our tutors are industry experienced professionals who are experts in their fields. So let us welcome our amazing guest for today. Let us welcome Emmanuel Ani. Emmanuel Ani will take us, before Emmanuel Ani take us into the real matter for today, I would like him to briefly introduce himself. I would like him to briefly introduce his topic before himself and the topic he has for us today. So Emmanuel, let's have you. Thank you.
All right. Thank you very much, Chika. I hope you can all hear me clearly.
Yeah, clearly we can.
All right, good. So today we're going to actually look at an interesting topic. As you've seen already, we're going to be looking at NumPy and the hidden math behind AI. So the idea behind this topic is just to unravel the magic that you think happens when you interact with any AI model, right? For most people, they really don't understand what happens. They just think it's like magic, like you just send a prompt and you get a response. What exactly is happening? So that is going to be what this class would try to achieve. All right. And I'm just going to set your expectations for this class. We are not going, um, it's not a deep dive class because of the, this is a master class, this is a boot camp basically. So it's just an hour or so. So we'll not be going deep into it, but we're going to be giving you sufficient knowledge to build your intuition on what exactly you need to know. So that's exactly what we're going to be doing today. And I believe before or at the end of the class, you'll definitely have a very good or solid knowledge on the topic. All right, so I just want to confirm from Chika if I can go ahead and start the class, or if you have any other thing to say.
Okay, yes, Emmanuel, you can go ahead. But before you go ahead, I'd like you to briefly introduce yourself to us in just a few
Oh,
seconds
oh,
so we know who Emmanuel is. Thank you.
okay, thank you very much. I think I skipped that. So basically, I am an AI engineer. I work as an AI engineer currently, but I transitioned from data science and ML engineering, and currently I I work as an AI engineer, so I really don't want to go into the details of every other thing. If you want to know more about me, you can quickly do a look up on LinkedIn, Emmanuel Ani, and you see me and every other thing that you might want to know there. So I'm happy to. I'm someone that loves sharing my knowledge on technical stuff. I love building, and I also love teaching and mentoring. It's something that I'm passionate about. So wherever you have things like this, if you just look a little bit, you'll see me there. So that's the kind of person I am. So I'm both a builder and a teacher as well. Right. So I've been into the data space for not for not long. I think about 3 4 years now. Started out as a data analyst, then transitioned to data science, then ML engineering, and currently AI engineering. So I kind of have a very strong background in this particular field. So I'll be glad to share the knowledge I have to everyone here in this meeting. So I hope that does justice to the introduction.
Thank you so much, Emmanuel. That's a very amazing one, from data analyst to data scientist and now an AI engineer. Wow, that's a very great one. So let's go. Let's get into it. We can't wait to see what you have for us today. So let's go.
All right. So today we are going to, let me quickly share my screen. Um, Please, can you confirm if you can see my screen?
Yes, please. We can see your screen.
All right, great. So I just want to confirm, is it possible to have this material shared to the participants? Because I think it might be useful to some of them. Is there any platform where they can get access to the material I'm going to use in this class? Or I don't know, but
Yes, yes, you can
uh,
actually drop it to us. You can drop it to us, then we can go ahead to share with them.
all right, because I believe some might just see a need for it. All right, so we have limited time, so I'll try as much as I can to go over everything we have for today. All right, so today we're going to be looking at a very interesting concept, or a very interesting topic, which is from NumPy to neural networks, the hidden math behind AI. So we have several sections of today's class. We're going to first try to build intuition on how AI works, basically. All right. Right. After that, then we'll move on to NumPy itself, introduce NumPy, talk about what NumPy is, and then talk about tensors as well and move ahead to start demonstrating how we can actually like create numpy arrays and all of that, perform some operations on numpy arrays, and then look at the application or the intersection between these arrays and arrays, tensors, and neural networks, because that's what we're trying to achieve. We're trying to like see how exactly the mathematical operations that you can perform in NumPy intersect with AI. All right. So we're going to look at few examples here and there, but nothing really deep. Okay. So if you want a more detailed explanation, which is not possible in single class, then you can consider looking at the options that Amdoranalytics will be giving. All right. So first off, when you get this material, you would require to follow up with every code that I have here. You'll be required to actually execute this code. All right. So you have to run this code, and so that every other thing that you'll be running or executing would not give you any issue. So that's it for that. That's for those that will be getting access to this material. All right. So let's have it. So now, it's nothing like strange at this point again, because we all have been interacting with AI, LLMs, ChatGPT, Gemini, Claude, and all of that. It's now becoming something that we are very much used to, right? So it's not a strange thing again. But early or late 2022, when ChatGPT was launched, I think September or so, it was like a very magical stuff. It was a magical stuff has happened, something out of this world, right? You literally ask the chatbot a question and it responds to you like a human would. It's very, very much human-like. So it was giving that semblance of human intelligence, just the way you interact with your fellow human being. In fact, at some point, it was even giving off more, it was even seeming more intelligent than a regular or an average human being, right? So people were just like curious, like, what exactly is happening? How are people able to come about this, right? To every other average person, to every other non-technical person, it was normal. Like, sorry, it was strange rather, all right? But to those that are already into the field, data science, machine learning, then we actually understood what was happening. There's something that has been going on for years. Research has been put into it, a lot of resources, like for decades, actually. All right, so that was the combination of years, decades of research, of a lot of research, basically. All right, so I'll try to now bring to give you that intuition exactly, right? Assuming that you don't have an idea of what is happening under the hood when you interact with this AI. So for a regular person, you send a picture to ChatGPT, or you type a prompt, a text, or even record an audio. All right. For us human beings, when we interact with data in our day-to-day life, we actually take them as it is, although there are nuances like and details and all of that, but it is not the same thing when it comes to this model. So this model don't actually see pictures, right? So that's what I want to establish now. They don't actually see pictures. They don't see the text or letters that you send to them. What they actually see, right, are numbers, all right? That's what they see and interact with. So that's exactly why it is important as an AI engineer to understand the inner workings of these models, right? So for example, if you send your model an image of a cat, what the computer will see is not a cat, right? What the computer will actually see are grids of numbers that represent the different pixel intensities of that particular image. So you can start to see how we would begin to link NumPy arrays to AI. So this is the first intuition that we'll try to build. So once you see a model interacting with any type of data input, the first thing that you should that should come to your mind is that, oh, this is actually interacting with numbers. So there are steps that are being put in place to translate or to process those input data to numbers. All right. So those things, like when you get to like take on AI engineering classes, then you are going to be taught all those things, right? But for the sake of this class, when you actually put in your data, it is translated directly to numbers. So those values are the things that the AI would now see and begin to perform computations on. All right. So in AI, everything is number, right? And those numbers live in arrays. So arrays are what we're going to actually be looking at in this class. So we'll talk about what arrays are later on. But for now, I just want to build intuition and get us to understand exactly what AI sees. So we are going to just quickly look at some code examples, but I will not be going through every single one of them because of time. So in this my code here, if you have access to this material, you can easily just execute it. And you see, so what we just did here was just try to demonstrate what AI or this model sees, right? So for example, if you have a picture, let's assume this black and white image you're seeing here is an actual image that you're seeing to your computer or to your model. So this is just 4 pixels. So in reality, when you're sending a picture, there are millions of pixels. So each of those pixels are represented by a particular number. All right. So in this case, you have, okay, this is actually not 4 pixels. This is I think 4 by 4. So this is 16 pixels. So you have 4 here, 4 here, 4 here, 4 here. Right. So if you send in this particular input to your model, what the model will see is not this thing that you are seeing on your left now, right? Rather, what they are seeing is this matrix, this number here, this set of my number. It's called an array. You can call it matrix, array, or tensors. We're going to also look at the differences between these different terms. All right. So this is what your computer will see, to see numbers, and it is on this number that the operations that would need to be performed will be performed on. Okay. So there's a translation from the input, right? So in this case, the input is an image to an array or a matrix, right? So I usually say that AI is, or deep learning rather, deep learning, AI, machine learning, there are differences though, but we use them interchangeably. It is basically matrix multiplication on steroids. All right, when you say something is on steroids, you are basically saying that it is to a very high level, right? So you are performing a lot of matrix operations in scale, in large quantities. So that's what gives AI that semblance of intelligence. Although there are nuances, there are things that you need to understand, all right, to make sense of those numbers. So let's just move ahead. So we've looked at images, right? So if you see an image, right, the computer doesn't see the same image, it sees numbers, right? So the same thing for text. So when you like passing prompts in text format, right, what the computer sees are actually set of numbers, right? They are arrays of numbers or an array of numbers. So in this case, you can see that each word here corresponds to a particular vector or array. So let me just use the word vector for simplicity's sake. All right. So you can see each of the words that we have here. We have king, we have queen, we have man, we have this and that. So all of them have their corresponding array of numbers. All right. So this is what the computer uses in its operations to actually understand the meaning of your sentence, the meaning of whatever it is you are passing it in as prompt, understanding the question you are asking. All right. So I'm just trying to simplify. There are a whole lot of things involved, but at the simplest level, this is exactly what happens. All right. So you have the same thing for image, you have the same thing for text, you have the same thing for audio as well. All right. So there are a lot of pre-processing techniques that would be applied to convert audio data to numbers, convert image data to numbers, convert text data to number. So at the end of everything, those things you are passing to your AI will be converted to numbers, right? That is what I want to establish here, right? That is the thing your model, your AI model would interact with, all right? So that's basically it for that. So I believe this has given you a very good intuition of what happens. Your AI don't just see things as you see it. They see number representations of those things. So now we're now going to move ahead to NumPy. All right. So whenever we talk about numbers or numerical operation, especially in Python, the library that should come to mind or that is commonly used is called NumPy. So for those of us that are not familiar with Python or anything that has to do with data science, I'm just going to do a quick explainer on that. So let me see if I can create a new notebook here. So whenever we are talking about numerical computation, numbers, and all of that, there's a particular library in Python that is specifically made for it, and that is NumPy. And that's why we are having this class, right? So if you are going to do any operations in Python, because generally AI is built using mostly Python language, all right? So Python is like the most commonly used language for model development. And one of the libraries that is popular for numerical computation in Python is NumPy, right? Although we are still going to talk about like tensors and all of that. For those of us that are familiar with machine learning and deep learning, right? So we have what we call NumPy, right? NumPy. So NumPy basically means numerical computation. Sorry, numerical Python, rather. So which is used for numerical computation. So any operation in Python that has to do with mathematical operation, any form of mathematical operation that involves number, obviously, would utilize NumPy, like at the basic level. All right. So if you want to do, even if it is not machine learning, even if it is something else, as long as it involves number, NumPy is your go-to library, right? So I'm not going to start explaining what libraries are and all of that. I would assume that you have an idea. But for those that don't have an idea, so libraries are just ways to extend Python capability. So Python is a programming language that can be used to just write code and write programs, right? So for those things that might not necessarily be available for you in Python itself, you can now extend it using what we call libraries. So it's just like you get a new phone, right? And when you get your phone, you don't have WhatsApp in your phone, you don't have Instagram, you don't have a whole lot of applications. So, but for you to extend the capability of your phone, you have to install new applications. So that is what NumPy is. So when you want to like perform this type of task, you now use NumPy. So, and the thing in NumPy that is going to be our focus is the particular data type that is used, which is called arrays. All right. So in NumPy comes with what we call arrays. So arrays is a specific data type that was built specifically for numerical operation. So if we actually use the regular Python data to perform mathematical operation, it is going to be impossible for us to get to where we are at this point in AI. All right. And this is possible because of one single concept called vectorization. So this NumPy arrays, all right, was optimized for numerical operation. So for big companies like OpenAI, Google, and all of those AI companies, you would realize that most of them pour in a lot of resources to acquire GPUs. And why are they acquiring GPUs? If you're familiar with GPU, you might be, if you're a gamer or you edit videos and all of that, you know that GPU is specifically made for numerical computation, all right? And these arrays that we have here, they are also optimized for this kind of numerical operation. So if we rely on the regular Python data to perform this numerical operation at scale, it is going to be very slow. It's going to be very inefficient. We would not even be able to get to where we are currently in AI. So this NumPy array is literally the foundation of what we can do in Python, or what we can achieve in AI. All right. Although this is not the end, but this is the starting point, and it is a very, very important starting point. So we're going to explain what arrays are. We're going to explain what makes them special, right? And how they actually relate, or how they are relevant to AI, neural networks, and all of those things. All right. So, but first thing is that arrays are a special data type, and we're going to see how to create them and how to perform some simple operations using these arrays. So I mentioned vectorization, right? So vectorization is another important concept. So I might be mentioning some new concepts, some concepts that you're not familiar with. Is very fine, all right? If you can take note of them, take note of them, right? You might not necessarily grasp it entirely in this single class. So, but I'll just try my best to explain what it is. So, vectorization is a very important concept that enables very fast operations on NumPy arrays. So, I would give an example shortly, but let me just quickly go over what I have here. So now we've talked about NumPy, all right? So NumPy is a library that provides a specialized data type called arrays that is useful for numerical operations, or that are used for numerical operations. So the alternative option to NumPy array is your regular Python list. So for those of us that are familiar with Python, we should know that we have different data types in Python, and one of them is your list. So if you don't have your array, you'll be left with the Python list. And using Python list for the operations that will be done in machine learning, deep learning, is going to be painfully slow. All right, it is going to be painfully slow, and that is why the developers of NumPy came up with this particular data type. So these are the differences between your normal Python list and your normal Python array. I'm sorry to those that actually are not familiar with Python. This we can't actually begin to explain all of this concept like list and all of that, but just know that that is not our focus. Our focus is just on NumPy arrays and how exactly it is relevant to AI and neural networks. All right, so there are differences between Python list and NumPy array that makes NumPy array to be very preferred. All right, so we have speed. All right, we have memory, we have math operation, and we have multidimensionality, and we have broadcasting. So I'll just go over this quickly. So for speed, right, I've said this over and over again. This is the main reason why we needed NumPy array. We needed a new type of data type. All right. So using Python list to perform mathematical operations that will be needed in data in AI is going to be very slow. So NumPy array comes in to solve that problem of speed. So there are implementations that enables this speed to be possible, right? So it's out of the scope of this class, but just know that NumPy array is very fast and it is optimized for mathematical operation. So for memory as well, so Python list takes up more memory space, all right? Why NumPy array take less? So I told you it is effectively, or it is a very efficient data type for data science, machine learning, and artificial intelligence, all right? So it takes up less space. So imagine when you're working on in a very large scale, you would want the space that this operation takes to be minimal, all right? Because if you don't take care of that space issue or memory issue, you would spend more, because what makes these AI companies able to provide these big models for us is because they can spend on GPUs. They can actually acquire these compute that are required to perform these operations. All right. So NumPy array has this advantage over your regular Python list because it utilizes lower memory, or less memory rather, for its operation. So for math operation as well, so Python list, it requires manual loop. So if you're familiar with loop or iteration in Python, you know what it is. So this is a very time-consuming operation. All right. So, but for NumPy array, it uses vectorization. So it is vectorization. I will explain that in a few minutes. All right. So this is another difference between them. So for Python lists, when you're working with multidimensional data, it's very difficult. All right, it's very difficult to actually work with multi-dimensional data. It was not built for that kind of thing. So, but for NumPy array, it is built in. You can actually have multi-dimensional data, and mostly you are always working with multi-dimensional data when it comes to machine learning, deep learning, and AI. Right. So the other one we have here is broadcasting. So that's actually a kind of operation that is available in NumPy arrays. So, but it's not available in Python list. So now we're going to quickly look at a practical difference between these two data types. All right. So we have your Python list. I'm going to create a Python list, and I'm going to create a NumPy array. The same exact value or the same number. We're going to perform an operation on them and see how much each differ from how much they differ from themselves. All right. So I've already written out the code here. So for those that would have access to this particular notebook, you can just check it out and play around with it. But I'm going to just go over it manually again so you understand. So we're going to demonstrate how NumPy array is way faster compared to your regular NumPy list. And this speed is important because when you are dealing with AI, you need to be very fast. Like you need your operations to be very, very fast, right, to save time and resources. So I'm going to come here and say comparing regular Python list to NumPy array. So I'm going to create a Python list. So I'll say Python list. So I'll create a range between 1 and 1,000,000. All right. So put 1 here. So this is your Python list. So I'll create NumPy array as well. So come and say NumPy array. So to create the NumPy array, I have to import my NumPy library. So import NumPy as np. So come and say np.arange. Do the same thing here. One. So I've created two variables now, right? I've created two range of number. This is your Python list. So if I check, if I come here and just check data type. So this is a range object. I have to convert this to a list. So this is a list object, all right? Let me just print it out properly. So you can see that this one here is a Python list, as you can see here, all right? And for the NumPy array, I'm just going to copy that. Just want to confirm their data type. And this right here is a NumPy ND array, okay? So you can see that we've successfully created a list, a Python list, and a NumPy array. So we will perform an operation on these two different data types and see how they differ in speed, in their speed of operation. So the operation we're going to be performing is just multiplying multiplying each value in that list or array by 2. Okay, so this is what we want to do. So let's say we have this range of value 3, 4, 5. So what I want to do is that I want to multiply each of them 2, 3, 4, 5. I'll multiply each by 2. So if I do something like this, np. So if I do something like this, so you can see that these two here would multiply each value in this array, all right? So 2 times 4 is 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and like that. So this is the operation we want to perform. But in this particular case, we have 1 million, 1 to 1 million values. All right. So let me even print it out so you'll see what we are working with. So this is what we're working with. So we have a Python list 1, 2, 3, 4, 5, 6, up to 1 million. All right. So that is exactly the amount of the range of value we'll be working with. And this is very small compared to the thing you'd be doing on average when it comes to machine learning. All right. So we have the same thing for NumPy array here. So if I print out my NumPy array values, you see that it's the same thing. All right. So we have 1, 2, 3, then this ellipsis, right, down to 1. So I think that one is clear now. So now let's perform the multiplication operation on both data type. So for your Python list, we're going to use what we call list comprehension to do that. So I'll just come and say for Python, let me say list results. So it's going to be something like this for x, okay, we'll do x times 2 for x in Python list. So if you're familiar with for loop in Python, this is just a shorter version of it. We're using list comprehension. So this is a list comprehension. All right. So what this does is that it multiplies each value in this Python list, right? So it multiplies 1 by 2, multiply 2 by 2, multiply 3 by 2, like that, and adds everything to a list. So it does that and stores it in this variable here. So we're going to time this operation, all right? We'll time this operation to check how long this operation took. So to do that, I will import this library, import time, all right? So and time, I'm going to say start equals to time.time, all right? And I'll come in and say Python list time is equals to start minus time dot time. Okay. So I've timed the time it took this operation to happen, this Python list operation. So I'm going to do the same thing for NumPy array. So I'm going to come here and just use my array. So for my array, so I'll say array results equals to NumPy array times 2. All right, so I'm going to time it. So start. So I'm say time. So should be this. I think this should be array start minus time dot time. All right. So it should come after here. Come after here. So I'm going to now print out the time. So print for Python list. taking for array or numpy array. So we are going to run this operation. So you can see that it has completed like in less than a second. So you can see the difference in the time here. So let me so you can see for Python list, it took us 0.49 seconds. All right. And for your array, it took 0.006. You can see how significantly better the numpy array operation is. If I increase this now to, let's say, 10 million operations, all right? So 10 million operations, and I run this, you see that it will actually take a little time. And you can see that for your Python list, the same operation, Python list took 2.76 seconds. That is almost 3 seconds. While your numpy array took 0.005 seconds. This is even less than one. It is very, very, very significantly different from your Python list. So remember, imagine how much effect or how much difference this would make when you have a whole lot more computations that are happening at the same time at a very big scale. So that is a whole lot. So that is one of the importance of having or using numpy array in ML, deep learning, and AI. All right. So that is a very, very important thing to know. So we're going to be moving on with some other operations that we have in NumPy. I will show us how we can create these arrays that we've been talking about. So I just wanted to establish the fact that arrays are very, very important. All right, NumPy arrays specifically are very important and a foundation of mathematical operations in machine learning. And this exactly is the major reason for it, which I just demonstrated. Okay, so we have other examples here, other things that we can like use to demonstrate the vectorized nature of NumPy arrays. So we have an array that we've created here, and we perform some operations on them. And if you go through this code and you run it, you see that it is very fast. It doesn't really take time. So it is just a very useful data type when doing machine learning. All right. So we've also probably heard of what we call tensors before now. So we've been looking at arrays, NumPy arrays, and all of that. But the particular terminology that is used in AI are tensors, right? If you have a question, you are going to wait to the end of.
Hi, Kenna. Please, if you have a question, can you kindly hold on while he's done so that we don't distract him? Thank you. So if you have any question, for anyone who has a question, just hold on till after the end of the section, after the end of his teaching, then we'll take train questions and go back to respond to them. Thank you. Please, Emmanuel, kindly go proceed.
All right, thank you very much. So now we're going to be looking at tensors. So we've established the fact that NumPy arrays are very useful for machine learning, deep learning, and AI. So what about tensors? What are tensors? You've probably heard of things like TensorFlow. Even for Google Pixel phones, their chip is called it has tensor in it basically. So almost everything that has to do with AI, right, would have tensor. So technically, tensors are conceptually tensors are the same as array, well, but with little differences. There are little differences between tensors and arrays, and those differences are just based on how the adaptation to training machine learning model. All right. If you are going to be training machine learning model, you don't use the arrays from NumPy directly. You actually use tensors. So tensors are tweaked a little bit to adapt or to align with GPUs. Right? You can't use NumPy arrays on GPUs, but you can use tensors on GPUs. So that's the major difference between tensors and arrays. All right. So arrays is just generally a collection of numbers, right, in matrices and different dimensional matrices. But tensors are the same thing. Tensors are array, but with a little tweak. So you can use these tensors on GPUs. So GPUs are graphical processing units. So they are what models are actually trained on. So when you're actually training your model, you use tensors. So the same idea we have already established, the same idea we've already established in NumPy array is that the same ideas that would have in tensors as well, with this specific difference. So, but let's just go over some things that you probably need to know. So when it comes to tensor, all right, we have different dimensions of tensors. Right, same way we have different dimensions of arrays, we have different dimensions of tensors, and we have what we call scalar. So whenever you hear of scalar, scalar is a particular value, is a value with no dimension, right? So it has no dimension, just a single value. So when you see a single number, 3, 4, 100, that is a scalar value, all right? It does not have a dimension. But moving ahead, when we talk of vector, so vector are usually of one dimension. So it's a list of numbers, right? So when we talk about vector, we're talking about a one-dimensional object. All right, then we talk of matrix as well. So matrix, if you remember your matrix operation in mathematics, so they're just two-dimensional objects, all right? So these have rows and columns. So I don't know if we'd have the time to start demonstrating all of that, but it's an interesting thing to know. So let me just kind of outline them here. So we have scalar. So scalar have no dimensions, all right? So example can be like a single number and all of that. So we have vector. So these have just one dimension. So example can be lists, right? Right. So this is just a general representation of vectors, right? So we have matrix. So matrix is when we now start stepping up the dimension. So we'll now be talking of two-dimensional matrices, right? So an example would be something like this. Let me come down here. So this right here is an example of a matrix, right? It has two dimensions, it has two axes. So you can see here the horizontal axis from left to right are referred to as rows, all right? We have 3 rows here, while the vertical axis from top to bottom is referred to as the column or columns, all right? So this is what a matrix is. And then we have tensor. Okay, so tensor in this normally, what tensors, when it comes to technical definition, they're usually multi-dimensional arrays. All right. So when you're working with higher dimensions, they're usually referred to them as tensors. But in practical use or in practical conversations or in day-to-day conversations, everything are usually used interchangeably. They are interchangeable. All right. So don't really put more attention to it. So we have higher dimensional objects. So from 3D, 3-dimension, 4-dimension, 5D, but you most likely not even exceed 4 dimensions, all right? So mostly 3-dimension and 4-dimension. That's going to be what you work with, right? When you're like just working with tensors and arrays. So now, as you can see here, we are going to quickly show us how we can create these tensors. We've showed you, and we are going to show us how we can create arrays and tensors as well. All right. So we've demonstrated some of this arrays operation already, showed us how they are faster than your regular Python is, but how exactly can we create them? So we can create these arrays, we can create tensors as well, NumPy arrays specifically, and tensors using different libraries in Python. So you already know the NumPy library, which I explained or introduced at the beginning. We also have libraries that can be used to create tensors. So when you're actually working with deep learning or machine learning project, right, you use this specific library. So they are called either TensorFlow or PyTorch. All right. So TensorFlow or PyTorch are the libraries that you would actually use to create tensors and train a model. So the OpenAI, Google, and the rest possibly uses libraries, right? PyTorch was created by Facebook, Meta. TensorFlow was created by Google, all right? So they use these libraries actually to train their model. So the particular data type that these libraries work with are tensors, simply because they can be adapted to work on GPUs, okay? So we have them using these libraries, right? So to create a NumPy array, we can easily just use one of the functions in NumPy. I don't know, I keep saying this because I don't know the type of audience I have, if they are beginners in programming or not. But to create an array simply, you just use this particular function, all right, numpy.array. I think we've done that already. And then pass a Python list in. So you can just put a list of numbers. So for one-dimensional array, you just put one bracket at each end and then put a list of number inside. So this is your one-dimensional array. All right, so I can come here and say array, this is your array 1D. All right. So for two-dimensional arrays, I can come and say array 2D. So simply come here. And I think I'll just pass this one that I've created here already. Just create this. And then pass it here. So this is a two-dimensional array. So this array is different from the one you create, the tensors you create in TensorFlow. So you can actually use these arrays to like you can use them in deep learning, or you can use them in AI. All right, you can just use them in your traditional machine learning that does not require GPU. So the only reason why you can't use them there is because those ones require GPU to execute faster. So GPU just kind of execute these operations at a very faster scale than your CPU. So we have 3D. So 3D, three-dimensional arrays are just like a stack of two-dimensional arrays. So we're going to have something like this. So I'll just copy this here. Remove this. So this is what a three-dimensional array looks like. I don't have time to start going into the details, right? But this is how you can easily create different dimensions of NumPy arrays, all right? So the same thing applies to tensor. So for tensor, to create tensors in Python, you have to import one of the libraries. So in this case, I'll be using PyTorch. So to use PyTorch, you import it, and you should have it installed already, right? This is not a Python class, so you can just like look that up. So you would import your PyTorch library using this particular command here, or this particular code here. So once you install it, you can now go ahead and create your tensor using this syntax. So torch.tensor, and then you can pass the same thing that you've passed here. So pass this list. So this one is for tensor 1D. Tensor 2D. Tensor torch. Tensor. So 3D. So dot so So I've created NumPy arrays and tensors. So these are the actual data that would be used during AI training, inference, whenever you're conversing or trying to use any model. This type of data, tensor data, are exactly what the AI is seeing. Okay, but obviously not in this dimension. So there are more complex dimensions. Some of them are 4 dimension and a whole lot of numbers, right? So you might not even see the numbers, right? You can just maybe examine the shape and all of that. But this is the same idea that has been implemented at the large scale. So you can see that we've looked at how we can easily create these tensors and this NumPy object. So I think we'll just look at some few operations we can perform on them before we now move ahead to see how they are used in neural network, because that's what we're trying to establish. We're trying to establish how this NumPy, where is that part? So how the NumPy and tensors actually like play a role in neural networks. So think I might not necessarily draw much on this part, but let's just look at it. So for arrays, we've seen that we can create an array using numpy.array. So we're going to look at how we can examine the dimensions of this array, because it's a very, very important aspect of it. Okay. This is a very important aspect of working with arrays. You need to know the dimension and you need to know the shape of your tensors or your array. So at this point, I'll be using tensors and arrays interchangeably, right? Because they mean the same thing and you already know the difference. All right. So let's just proceed. We would now examine the shapes of these arrays we've created. So for this particular one here, this NumPy arrays, we have 2-dimensional, we have 1-dimensional, we have 3-dimensional. So to get the shape of this array, I'll just easily use this code here. So array 1d dot shape. This is a 1-dimensional array, right? And it's telling me that it has just 3 rows present. Okay, it has just 3 rows. So it does not have another axis. That's just one axis, and in that axis it has 3 rows basically. So for 2D, we're going to have 3 by 3. So this is a 3 by 3 matrix. So what this means is that it has 3 rows and 3 columns. All right. So if you, let's say, change this shape here, if I add one more number here to the rows, you see that it has changed. So now it's 3 by 4. All right. So when you're working with arrays in AI, or when you're building a model, basically, right, it is very important that you assess the dimensions of your data, whether your input data or your output data or the hidden layers, right? So this is a way to easily examine the shape of your data. So you can see that this just tells us the number of rows and columns that we have. So for the 3-dimensional array, it's the same thing. So it would have 3 values representing the shape. So we're going to have 2 by 3 by 3. All right. So what this 2 basically means is that we have 2 stack of 2-dimensional arrays here. So we have one here and another one here. So if you have a third one, so let me just copy this and add it here. If you have a third one here, these 2 here would become 3. All right. So it will be, so that's what this first value corresponds to. So the second value here now and the third value corresponds to the rows and column in each of these 2-dimensional array. So each of them have 3 rows and 3 columns. So that's why we have 3 by 3 here. All right. So if I run this now, it will be, well, let me execute this first and come here. So Okay, I was putting it in this tensor. Yeah. All right, you can see we have 3 by 3 by 3. All right, if I change one of these here, let's say I remove the last row here. I remove the last row here as well. And I remove the last row here as well. You notice that the shape will change. All right, the shape here would what. So I think there have been a okay, yeah, yeah. All right. So sometimes you just you see that the shape here has changed to 3 by 2 by 3 because now we have 2 rows, all right, instead of 3. So this is basically how you can check the shape of your array by examining the rows and columns and also the number of 2-dimensional arrays in your 3-dimensional arrays. If it is 4-dimensional array, it's going to be 4-dimensional array is going to be a stack of 3-dimensional arrays. So you're going to just have 4 values that will correspond to that. So it becomes more complex as you go higher and higher in the dimension. All right, so that's how you can easily check your shapes, the dimension of your array. So there's another function here that can help you, or attribute rather, that would help you to get the dimension. So it's just ending. So once you apply that to your array, you get the dimension. So for 3-dimensional array, this is 3. For 2-dimensional array, this would be 2. For 1-dimensional array, this would be 1. All right. So that's it for the dimensions and the shapes of arrays. So the same thing applies to tensor actually. I think they have the same API. So if I come and say tensor 1D, dot shape, you see it gives the same thing, all right? So if I say tensor 2D dot shape, the same thing here. Tensor 3D dot shape, the same thing. All right. So they basically have, so they are the same, they're conceptually the same thing. All right, but on an implementation level, they have nuances, there are differences that just helps tensor to perform better on GPUs. All right, that's why tensors are more used when it comes to building AI models. All right, so let's proceed with the operations that we can perform. So at this point, I'm just going to try to go as fast as I can so we can cover up so we don't waste much time. I've showed us how we can create arrays, right, using np.array. So we have other methods. We can use np.arange, which I showed you earlier when I was trying to compare the speed between NumPy and Python list. So we have this function as well. So we have other functions we can use, but we don't want to like go into all those things because of time. But the one that you need to know is np.array and np.arange, right, that you can actually use to create arrays. So when you get this material, you would probably need to go through it in details so you can look at each of the code and what they do. All right, I've already showed us how we can check for dimensions and shape. So the same thing applies here. So you can just use the same code I showed you earlier to check for the dimension and the shape of your array. So you might think that, oh, why am I going to disturb myself with dimension and shape? Most of the issues that you'd encounter when working with matrices is almost related, or it almost relates to the dimension of a particular array you're working with. So if you don't understand how to confirm a dimension on or how to like check for the dimension of array or the dimension of the array you're working with, you would mostly be frustrated. So it's very, very important that you understand that this dimensionality is a very important concept when working with arrays. So we have other things that you can perform on numpy arrays. We have indexing and slicing. All these are just basic operations that you can perform as well. All right, that is not part of the core thing we need to discuss today. So we'll just go over that. So let's now look at how this is relevant in neural networks. So how exactly the neural network computes their output, right? So I'll take you through the steps, and we're going to just wrap it up there. So when you, let's say we have a particular model, and that model job is to predict whether a particular image is a cat or not. Okay, so you have a model, and that model job is just to make predictions on an image, and it's a classification model. It should predict whether this image is a cat or not. So what are the steps that this model would go through, right? And how does it relate to arrays? So the first thing is that you have to pass in your input, all right? So you pass in your input. So your input will be, okay, let's assume that your input has been processed already to numerical representations, because when you put your image or upload your image, it doesn't get the exact thing. So it is going to have to convert it to numerical representation, all right? So we pass your input, and then it is now going to perform what we call matrix multiplication. So this matrix multiplication is when the AI begins to actually learn patterns from that particular input. So it's perform matrix multiplication using this linear equation, which is y is equals to mx plus b, something like this. So let me just like this. AW, all right? So this is the equation that every neural network like applies to make sense of a particular data, all right? And this particular part of the equation here, right, is where matrix multiplication occurs. And each of them are actually arrays. They are tensors basically, and these tensors would be multiplied together and added to a particular another vector. So this B here is a bias, a vector, to give you an output. So this output will now be taken in as an input for another layer. So let's say we have another layer, layer 2, right? The same thing will happen until you get to your final output, which will now be a prediction. So it will be a prediction value between 0 and 1, all right? So this is just the flow of a very simple neural network, all right? You get your input, and this A here is going to be, let me just make it, this is your input times, this W here is going to be your weight, all right? So this B is your bias. So this weight is a random value that will be initially added to all the inputs. So what the neural network tries to learn is how it can tweak this weight, all right, so that the loss value, because when it makes an initial prediction, it will compare to the original prediction to see if it is correct. So that difference between the original and the prediction would now determine how much tweaking or how much change will be applied to the values of this weight. And these weights are actually arrays. If your input is, let's say, 1,000 by 1,000 matrix, your weight will also be 1,000 by 1,000, because each of them would have their own specific weight value. All right. So the matrix multiplication between these two matrices would now be added to this bias, and it will give you a particular value, which would now be taken to the next layer, and the same thing will be performed until you get to the last layer. I really wish we have time so we go through exactly how this happens. But what I'm trying to like just drive at here is that arrays are exactly what are being used in all these operations. So each of these terms here, bias, input, weight, all of them are actually arrays, all right? And these are the things that the model sees during training and even also during inference when you're trying to make prediction, okay? So at the end of the whole thing, NumPy arrays plays a very important role in neural network, in AI itself, all right? So it's something that anybody that is going into AI engineering or machine learning would need to know. So I think we're going to just wrap up at this point. I'll just summarize here so that we can wrap up with this class. So if you want more or a deep dive into this, then you can consider taking up one of our courses, AI engineering, so that we have more time with you. So we've looked at several concepts here, right? We've looked at how AI sees numbers and not the raw data, and how those numbers are usually like organized in arrays and tensors. And we looked at the different dimensions of arrays and tensors and how we can actually ascertain the shape of these arrays and tensors, and how the core operation of a neural network utilizes these arrays as well, all right, to perform their operation. And yeah, so that's basically how NumPy, that's basically the hidden math behind AI, and how we move from NumPy to neural network. I know this is little bit rushed because of time. This kind of topic usually spread out across weeks, so we're just trying to cramp everything down and give you a good intuition, or just give you an idea basically of what you should know about this. So thank you very much for your time. I think I'm going to be passing on if you have any question at this point, you can ask actually. But I'll be passing on okay, give me a second. Okay, I'll be leaving it on to Chika to take over from here. And if you have questions as well, I think you can raise your hand at this point. So I think I'll be taking questions. So after the question, Chika will take over from there.
Thank you so much, Emmanuel. Thank you for that amazing and impactful section. Thank you. It was really insightful and amazing. Okay, so it's time for question. If you have any question for Emmanuel, please kindly raise your hands up so that we can take it one after the other. Please kindly indicate by raising your digital hands up if you have any question, you need more clarity on something. Just kindly let us know by raising your digital hands up. Thank you. I think we had someone who raised his hand. I don't know. Yes, I think.
Yeah, there was someone who raised his hand before. I don't know if
Yeah.
it was a mistake or so, but if no one is raising their hand at this point, I think probably don't have any question.
All right. So if no, yes, he's raising his or her hands up. That means we all understood perfectly what our trainer said. All right, thank you so very much, everyone. So let's dive into the second part of this section. So what we just listened to is the first part, and we are about to dive into the second part. And after the second part, we'll be rounding up. So I'll proceed to share my screen so we can see the second part of this training. All right, please kindly confirm you can see my screen.
Yeah, I can see your screen.
Okay. All right. So at Amdoranalytics, we're currently having a 90% discount scholarship offer currently ongoing. The reason why we're actually doing this is because a lot of people have actually indicated interest in our training, and some of them said, oh, I really want to transition into the tech space. I see what you guys are doing and I really want it. I want to earn so much. I have friends who are in the tech space who are actually earning enough money. So right now I actually want to do that, but I don't have the funds to take for the training. So these people are actually the ones that made us to actually give this discount that we're currently running, right? Is a 90% discount. And trust me, you don't want to miss this. So you will be taking trainings like cybersecurity and AI engineering for 150,000 naira. Yes, you heard that, 150,000 naira. While you'll be taking HR analytics, data engineering, data science, project management, and business analysis for 100,000 naira each. Yes. So aside the training, there are different benefits. There are a whole lot of benefits on why you should train with Amdoranalytics, why you should train with us here at Amdoranalytics. So the first one is practical job ready training, just like what we saw right now. We saw today is a practical training, hands-on experience training. So nobody is just coming to give you recorded versions and say, go and read this. Nobody is giving you scripts to read. It's a hands-on practical. If not because of our trainer, Emmanuel was trying to like cut down the time, was trying to like, work with our time. You can actually tell that if we had allowed him go for extra 1 hour, you can see that this is just a practical training. And we don't just train, we don't just hire anybody to train. We don't hire students to train. We train experts. If you actually, for those of us that joined this training, while Emmanuel introduced himself, he introduced himself and he said he started off as a data analyst. He started with data analytics and he, as a data analyst. From data analyst, he moved higher to a data scientist. And from the data scientist, he transitioned into the AI engineering space. So these are the kind of people we actually bring on board. These are the kind of trainers we bring. We don't just bring someone who does not know anything about the training, probably someone who just finished their training 3 months ago and they're teaching you. No, our trainers, I can actually tell you, our trainers are experienced and some of them have years of decade experience in the training industry. Like our data analytics trainer. Yes, our data analytics facilitator. She has been in this game, in the data space for over 10 years. So tell me why you wouldn't want to learn from such person. And another thing is industry standard tools and technology, just like what you saw Emmanuel did today. He gave us he showed everything. He didn't leave anyone unkept, right? We don't hoard information over here. We don't gatekeep over here. We give it to you as she should be. If not because of time, we can go on and on for this section for 2-3 hours, and you can actually tell by yourself if you really want to train with us or not. Another one is expert instructor with real experience, and that's what I just explained right now. And we have personalized mentorship and support. So if you're training with Amdoranalytics, be rest assured that you have 100% mentorship and support from us, a lifetime mentorship and support. Yes, you heard that right, lifetime mentorship. So even after the training, it doesn't just start and end after the training. After the training, we also mentor you, we support you through your journey. Even maybe you started as a data analyst, right? Just like Emmanuel started, and you say, oh, I think right now I want to transition into the data science or AI engineering or the cybersecurity space. We are actually here for you to help you, support you, and mentor you. So if you actually take any of our trainings, just be rest assured that you are already in our community and you have our 100% support and mentorship for lifetime. So another reason why you should train with us is flexible and friendly beginner trainer. So you don't really need to have any background in tech. A couple of people call us and they say, oh, I really want to transition into the tech ecosystem, but I was told I will need a science background. No, you don't need a science background. In fact, the founder of Amdoranalytics studied economics in school. Right, she studied economics in school, and I myself, I studied microbiology, and I'm already in the tech ecosystem. So you don't really need to have any background in science. You don't really need to have any tech background. All you need is your willingness to learn. Are you interested? Are you willing? If you are willing, then yes, you can actually train with us because our trainings are beginner friendly. Then the next one is certification that boosts your CV. Our certificate is globally recognized, it's internationally recognized. So you don't have any issues like, oh, collected the training and I was told it's not recognized. Anybody telling you Amdoranalytics certificate is not recognized is just actually lying to you. Our certificate is internationally recognized. So what that means is that you can train with us and make use of a certificate from anywhere, around anywhere in the world. You don't need to only be in Nigeria to use the certificate. You can actually use it internationally. So another reason why you should train with us is career guidance and portfolio development. A lot of people in the tech training underrate portfolio development. I cannot overemphasize the importance of career guidance and portfolio development. Some of the tech people who transition into tech, let me just say students, after their training, they start sending CV, they start using CV. You can't just use only CV to win the heart of a recruiter as someone who is actually in the tech industry. You need a portfolio. What is portfolio? Portfolio is actually hands-on, everything you've worked with. Just like for instance, as a data analyst, you are trying to let them know in your portfolio, even if you don't have any real world, even if you don't have any experience, right? Your portfolios actually tell them what you can do and what you've done. And at Amdoranalytics, we give you the opportunity, we help you build your portfolio, and we teach you how to build your portfolio from the scratch. Right, so everything you have done as a data analyst, you worked on data, you actually turned raw data into insight, you were able to clean data, analyze data, you can actually use Python, and all these things will actually be in your portfolio because recruiters want to see what you can do and not just what you studied. Recruiters are not asking you, okay, what did you study? Oh, you did. Yes, what you study, your certificate matters, but then your portfolio matters more because they want to be sure that they are hiring. They're actually trusting somebody who knows his or her onion in the space. So another one is supportive community. At Amdoranalytics, we have a supportive community. For those of you here who are already in our group chat, you can actually tell our community is supportive. You can actually drop message at any time at all during the day, even at night, and you will get response, right? And we have proven success stories. The success stories we have are a lot. You can check our website www.amdoranalytics.io to see success stories from our past students, and you can actually follow us on social media, on our social media, to actually see reviews proving success stories of our past students. And the last reason why you should train with Amdoranalytics is affordable quality training. Trust me, you cannot get all this value I mentioned for 100,000 naira. You cannot get it anywhere. You can, and the 100,000 naira is not just for 1 month, it's not for 2 months, it's for 12 weeks, 3 months. So tell me, who can do this if not Amdoranalytics? It's only Amdoranalytics. You can actually get all this I actually mentioned here at Amdoranalytics. So if you're really interested in any of our trainings, you want to take our trainings, you want to speak to any of us, please reach out to us. You can reach out to us on social media. You can actually reach out to us via our website, anywhere at all. Just tell us you want to consult, you want a free consultation. And the good thing is that you don't need to pay for consultation. Consultation is absolutely free. You can speak to anyone. You can speak to myself. You can speak to the CEO. You can speak to my colleagues, our other team members, and probably you want to transition, but you don't know. Of course, there are a lot of noise in the tech ecosystem. Some people are saying, oh, cybersecurity. Now everybody wants to do AI. But the thing is AI really in your career path? Can you really scale through in the AI ecosystem? So if you're really confused, you need clarity, you can speak to any of us. You can schedule a call with us, and it's totally free. So thank you so much, everyone, for joining. If you actually stayed to this point, it actually means a whole lot to us. Thank you so very much for joining. Thank you so very much. Thank you, Emmanuel, for sharing that amazing insight. Thank you, everybody. See you in our next one. Have an amazing day ahead. Bye.